All right, how's everyone doing today? What we're going to get started on today is the first part of section 4.6. We spent the last couple of weeks talking about shortcuts in which we can, ways in which we can find two triangles are congruent to each other. All right, and we've got a list of 4 shortcuts, and I'll ask you to review those in just a few minutes. But the whole idea, again, the reason why we're going through this logical process is we're trying to get to the point where we have congruent triangles, because once we know triangles are congruent, then any corresponding parts are equal. So in the picture I've drawn for you guys down below, if somehow we were to know, somehow we were able to figure out that triangle ABD and triangle CBD are congruent to each other, if we're told that or we can figure it out, then any corresponding parts have to be equal. So therefore, the angles at A and C that I decided to call 1 and 4 would have to be equal. The corresponding angles at B for the 2 triangles 2 and 5 would have to be equal. The angles located at D for the 2 triangles 3 and 6 would have to be equal. And then the sides opposite each of those pair of equal angles. Now, of course, the last one's obvious. Something's always equal to itself, but still, those are corresponding parts of the left and right triangles. So that's the whole idea. I do want to remind everybody about the abbreviation that we use when we do have congruent triangles. And we want to talk about their corresponding parts being equal. That abbreviation, once again, is CPCTC. All right, 5 letters, acronym that means or stands for congruent parts of congruent triangles are congruent. Now we could just as easily make that last letter an E, but you get the idea. Corresponding parts, all right, so the ones that match up, corresponding parts of congruent triangles. Okay, there again is the part that we've been working on now for a couple weeks, making triangles congruent. Corresponding parts of congruent triangles are either congruent or equal. Okay, so that's the idea. Now, let's just do a quick little bit of practice to put it back in everybody's head. If I were to give you a couple of triangles, let's just do a little bit of practice with making sure we can prove that the triangles are congruent, and then having it in our head, which of our shortcuts are we then using? Okay? Now, if I'm going too fast at any point in the video today, feel free to pause so that you can get anything you want written down on in your notebooks. Okay? So here's the first example. We have triangles ABC, DEF. Can you prove the 2 triangles are congruent? This is going to be a yes. Oh, sorry. Let me hit the pencil. There we go. So this is going to be a yes. And which method would we be using? Well, please notice that each of the triangles is a right triangle. You see the mark for a 90-degree angle. And then please notice that you know the side opposite the right angle and the side opposite the right angle are equal. And those sides opposite the right angles are called the hypotenuse, so we would know an H. Then the other thing we're told in this problem is we're also told that one of the other sides in the left triangle is equal to one of the other sides in the right triangle. And the sides that don't make up the right angle are called legs. So the other thing we know here is an L. So the shortcut we'd be using here is HL. Okay? I'm just going to buzz through a few more. Again, feel free to pause the video at any time if you need to write something in your notebook. Okay, next one. Can you prove these 2 triangles are congruent? If yes, then which of the postulates or theorems are you using? This, once again, is going to be a yes. In fact, all of ours today are going to be yeses. But which shortcut are you using? You might be tempted to go right back to HL because we have right angle equals right angle. But this time we do not know anything about the hypotenuse. Let me draw a temporary arrow. We don't know anything about the hypotenuse there or there. So we're not going to be able to use, even though we have a right triangle, we're not going to be able to use HL. What else do we know in the problem? We know that angle I and angle J are equal, so these two fellas are equal. So right away we actually know two angles. We know two angles are equal. So if we were to write that out, we know angle H equals angle L, and we also know angle I equals angle J. Okay, are we told anything else in the problem? Yep, we're told one side in the left triangle equals one side in the right triangle. HG equals KL, right? So we know a side. Now, not that, as we've talked about, not that it's really important, but when we know two A's and an S, it doesn't really matter. It doesn't really matter if the side is included. So it doesn't matter if the side is in the middle or on the end of the shortcut, right? We're saying that both of those are the same. Both of those are equivalent. So don't worry about which one is which. Okay? Alrighty. Next one. This is probably a little bit of an easier one. Again, these triangles are going to be congruent. Which of the shortcuts are we using? Well, I'd show you that JK and KL are the same length, so we know a side. I show you that JM and LM are the same. We know another side. We don't know anything about an angle initially anywhere in the problem, but the two triangles share a side. And let me make it green or something. The side that they share is side KM. KM in the left triangle is going to be equal to KM in the right triangle. So something is always equal to itself using the reflexive property. So that would give us a third side. So this would be a yes using SSS. All right, and I've got one last example. Right, what would you use to prove that these two triangles are congruent? All right, again, feel free to pause the video at any time if you want to jot this down. But why would you know these two triangles are congruent? Well, I'm telling you that side PR and TR are equal, so I'm giving you a side. Then I'm telling you QR and SR are the same, giving you a side, right? And that's it, that's explicitly given to you. So where else are we going to get some information? Well, the thing we'll always remember is when we have intersecting lines, vertical angles are also equal. So the two angles that are, the angle in the upper and the angle in the lower triangles are equal. And whenever we're in the two sides in an angle situation, the angle has to be included. And is it here? The green angle, is it in between the two red sides? Above? Yep. How about down below? Is the green in between the two reds? Yep. So therefore, the angle is included, and so we'd be using SAS. All right, so there's just a few examples of those yes-no questions, just to kind of put that back in everybody's head. And then the rest of today, what we're going to do is we're going to run through some examples of some proofs where we have to use the corresponding parts. Okay? So feel free, I don't know, I'm just going to kind of keep an eye on the clock to see how many I can get done here. Feel free to jot down as many as you wish. You for sure need a couple of these at least though. Okay, so you can see I have a diagram set up, I have some given information set up, and I have something I want you to prove set up as well. Okay, so the diagram, I'm going to tell you that TU equals TW, I'm going to tell you UV equals WV, and then I'm going to ask you to prove that two angles are equal. So these two angles, U and W, I'm going to ask you to prove that those two angles are equal. Okay? So feel free to pause, and then when you're ready to go, here we go. So start off with the given information like always. So start off with TU equals TW given, and get in the habit of putting some marks on your picture to help you out with what's going on. So I put a tick mark on TU and TW. Next, UV and WV are the same length. So that's given. Okay, again, some tick marks. UV and WV are equal. All right, so that's the given. Right? Now what what I'm trying to get to is I'm trying to get to the point where I can say angle U and angle W are equal to each other. Right? Now there's no information on the picture that leads you directly to that. But if we could prove the two triangles are congruent, then those two angles would have to be equal because they'd be corresponding parts. All right, so that's the strategy. First, prove the triangles are congruent. Then, we could use corresponding parts to say any other pieces that we don't already know about are going to be equal. All right, so it's going to go something like this. By the way, right now, where we're sitting, we have a side of each triangle, and we have a second side of each triangle. So right now we have two S's. So to get to one of our shortcuts, we need an angle or we need another side. Can you see where it's going to come from? We've done this one a couple of times, so hopefully it's starting to come to mind. We're going to be able to say that TV in the top triangle is equal to TV in the bottom triangle. Now something is always equal to itself using the reflexive property. And so in terms of the picture, what that tells me is TV in the top equals TV in the bottom. So I'm going to put 3 tick marks there. And what that gives me is a third side for each triangle. Is that one of our shortcuts? Yes. Therefore, we can say that the two triangles, the upper, T, U, V, would be congruent to the lower triangle, T, W, V. And the reason the two triangles are congruent is 3 sides. 3 sides of one triangle equal 3 sides of another, right? And now that we have congruent triangles, let me use the highlighter. Now that we have congruent triangles, that's the important step. And now, any other missing pieces, anything we don't already know about, have to be equal as well. And the one we're concerned with, of course, is that angle U has to be equal to angle W. All right? And again, the reason those are corresponding parts, our abbreviation CPCTC, which again stands for corresponding parts, congruent triangles are congruent. Or if you want to put an E for equal instead of the C at the end, that'd be fine. Okay? So we're done. But if on a different problem if we ever needed to, we could have also found that this little angle at T in the upper equals this little angle at T in the lower, or this angle at V in the upper triangle would be equal to this lower angle at V, this angle at V in the lower triangle. Those are also corresponding parts. Now I just happened to ask for U and W, but I could have asked for any of those. Okay? You can see it's not a very long problem. Maybe I set you up with one that was a little too easy, but hopefully you starting to get the idea there a little bit. Okay? So let's move on. Again, feel free to pause the video anytime you want, but let's move on to another example. And I'm just going to shrink that slightly so you can see all the letters. That should be okie doke. All right, so here's another picture you're kind of familiar with. This time I'm giving you that AC is equal to EC and angle B equals angle D. And then what I'm asking you to prove is that AB is equal to DE. All right? So pause the video, write down the diagram, write down the given and the proof, and then turn it back on when you're ready to go. Okay, I'm going to get started with the given like always. AC equals EC, given. And I'll continue to put marks on the picture to help me out. So AC equals EC. Next, angle B is equal to angle D, given. All right, and so B is right here, D is right here. Okay, so that's the given information. Now again, what we're trying to get to is AB equals DE. That's what we're trying to get to, right? Those two have to be equal. How do we get to that? We first have to prove that the two triangles are congruent to each other. Once the two triangles are congruent, then any corresponding parts are also going to be congruent or equal. Okay, so how do we get there? How do we get that job done? Well, we have to get to one of our shortcuts, SSS, HL, SAS, or AAS, in whatever order you want to use that fourth one. We have to get to one of those. So what else can we figure out about the picture? Right now we know a side of each triangle is equal, and we know an angle of each triangle is equal. So we know an S and an A. We either need to get to another S or we need to get to another A. Can anyone see how we're going to get that done? All right, I'm going to lead you there if you're not sure. I'm going to put them in green. I'm going to ask you to call this angle right here number 1 and this angle right here number 2. And then what we're going to be able to say is that angle 1 is equal to angle 2. Why are those two angles equal? Because we have two intersecting lines, and so those angles are vertical angles. So they have to be equal to each other. So maybe, I guess I'll just do it in green. So this angle and this angle are equal. And what that then gives us is another A. All right, so what we have is one side and two angles. Is that enough for one of our shortcuts? You bet. So now we can say, let me switch back to white. Now we can say that the triangle on the left, I'll call it A, B, C, is going to be congruent to the triangle on the right. I'll call E, D, C. And I'm pretty sure I matched up, the corresponding vertices there. Pretty sure I did. A, B, C, E, D, C. Yeah, I think I did okay. And the reason, you can see it in the margin, is two A's and an S. And again, it's not important if the S goes in the middle or on the end. I told you guys, I'm not going to grade you on where you put it. So either one is good. Again, I'll choose my highlighter. Once we know these doggone triangles are congruent, then any corresponding parts are going to be equal. So now we can put in our last statement. We can say AB is equal to DE, and I'll highlight those like I've been doing. Let's see, AB is this fella right here, and DE is this one over here. Those two sides are going to be equal because they are corresponding parts of congruent triangles, and those are going to be congruent, or again, if you want to use an E on the end, that's fine as well. Okay? So we're continuing to get to the point where we're proving triangles congruent, and then usually taking one, sometimes we need two little extra steps to get to what we're trying to prove. Okay? Another example right here. Again, feel free to pause the video and get the diagram down, get the given and the prove down. Once you're ready, hit play again. And like usual, I'll get you started with the given information. So angle 1 equals angle 2 is equal to 90 degrees. All right, so like usual, I'll put that given in red. Angle at 1, angle at 2 is 90 degrees. Okay, next up, VW is parallel to UX, given. Now remember, the symbols for parallel in a picture are little arrows. I'm going to put an arrow on VW and an arrow on UX. So those two folks, those two lines are parallel to each other. Okay? Alrighty. So what we're trying to prove on this one is that UV and XW are the same length. So I'll put those in a color just so you can kind of see them. They stand out a little bit. UV, kind of this vertical side over here, and XW, this vertical side over here. Okay, somehow we got to prove that those two are equal. Again, to get that job done, we start by proving the triangles are congruent. All right, how can I prove the triangles are congruent here? Well, because we have right angles, you might be tempted to try HL, can you prove hypotenuse and a leg? All right? The trouble on that one, trying to use that one, is that the H, the hypotenuse of each triangle, you don't know are equal. There's nothing in there that talks about those being equal. So good thought, but unfortunately HL isn't going to get the job done. Could give it a try, but it's not going to end up working. So if HL doesn't work, we have to revert back to just sides and angles. So what are we told right off the bat? Angle 1 and angle 2 are equal, so that's actually an A in both triangles. Okay? Now look back to the picture, look back to the given. What else do we know? What else can we figure out? Well, we have a side that's being shared between the two triangles. The side that's being shared, used by both, shared between the two triangles is the line UW. UW is a side in the upper triangle, and UW is a side in the lower triangle. And of course, anything's going to be equal to itself using the reflexive property. So what that then gives us, I'll put a tick mark on it. That then gives us a side in each triangle. Right? So we're doing pretty well. We have an angle A and we have a side S. To get to congruent triangles, we need another A or we need another S. Right? And can you see where we're going to get them? Please notice on this one, I haven't yet used the fact that the lines are parallel. We'll rarely give you guys information that you're not going to use. So how would I use the parallel lines? Well, since we have two lines that are parallel to each other, if you think about the green line as being the transversal, then this angle that I've marked in red and this angle that I've marked in red, I'll call this one number 3 and this one number 4. Those have to be equal to each other. So angle 3 and angle 4 are going to be equal. Now I wish I was in person so I could ask you guys and actually have a real pause and wait for a response, but why are those going to be equal to each other? Because angles 3 and 4 are alternate interior angles. So let me put some tick marks on 3 and 4. And what that gives you then, guys, is another A. All right, so what do we have there in the margin? 2 A's and an S. 2 A's and an S. Is that one of your shortcuts? Heck, yes. So therefore, the two triangles, the upper, I'll call it V, U, W, is going to be congruent to the triangle down below that I'll call X. And let's see, I got to go up to W and then over to U. And the reasons in the margin there, 2 A's and an S. And sorry to be a broken record, the S, it doesn't matter if it's in the middle or on the end. Okay? And then finally, once we get to the point where we have congruent triangles, then any other corresponding parts are going to be equal. And that's when we can finally state that UV and XW would have to be equal to each other because those two sides, I think I've marked them in yellow here, are corresponding parts of congruent triangles are equal. And again, feel free to either use an E or a C at the end. Okay? So again, just to repeat, sorry to be a broken record, but we're trying to get to congruent triangles so that then any other part that we don't already know about has to be equal. Any other corresponding parts. Okay? And again, that usually requires just one more step. Sometimes two, but usually it's just one more step. All right? So, to finish off then, I've got one last proof, and this is going to be one that actually requires 2 steps at the very end. 2 steps at the very end. Okay? So once again, feel free to pause the video to write down the diagram, given and the prove. And then turn the video back on when you're ready to go. All right, so I'm going to start with the one piece of given information. C is a midpoint of BE and AD. That's given. All right, now because C is a midpoint of BE, you can then say that BC and EC are the same length. BC and EC are the same length. And what you're using there is the definition of midpoint. Midpoint is a point that's halfway between or in the center of a line segment. Okay? Similarly, because C is a midpoint of AD, we can then say that AC and DC are the same length. So AC and DC are the same length. Obviously using the exact same reason, definition of midpoint. All right? So what we get fairly quickly is we get two sides of the triangles. All right? Now the next step I hope you're kind of expecting, if I call this angle 1 and angle 2, I hope you're kind of seeing this coming because we've done this one several times. We're able to then say that angle 1 and angle 2 are equal because those two folks are vertical angles. So angle 1 and angle 2 are equal. And what that gives us, of course, is an angle. Remember, with this abbreviation with two S's and an A, we just need to make sure the angle is included between the two sides. So is angle 1 included in between the two equal sides in the left? Yes. Is angle 2 included between the two equal sides in the right triangle? Yes. So therefore, the two triangles are congruent. So I'll call this one triangle ACB, and the one on the other side then would be DC, whoops, sorry, that's wrong, DCE. And the abbreviation off in the margin, SAS. Now I've said on the last couple of examples, usually it's just going to be one more step at the very end. But this is an exception. This one we actually have two steps at the end. All right? And so to finish this one off, what I have to be able to say then is that the angle, in fact, I'm going to just skip the numbers. I'm just going to stick with the letters. I think I'll stick with the letters. I'm going to start by saying that angle B is equal to angle E, right? And I'll put a green tick mark there just so it draws your eye to those two. So B and E are equal because those son of a guns are corresponding parts of congruent triangles are congruent. Now I know that doesn't match up with our proof statement. So we need one more thing. But once we have B and E being equal, now what I need you to do is think of AB and DE as being lines, and then BE is a transversal. And so what we'd have is two lines cut by a transversal and the alternate interior angles are equal. And that allows you to say then that the lines are parallel. Tough reason. It's easy to say alternate interior angles, but we need one more word to be precise. And we should have the reason alternate interior angles converse. Right? We had to first show the alternate interior angles were equal. Then we could say that the two lines are parallel to each other using that converse theorem. Okay? So there's a few examples. None of them are too terribly bad. How long is this last one, guys? 1, 2, 3, 4, 5, 6, 7 steps. So it's getting a little bit longer, but the earlier ones weren't so bad. Okay, so just a little bit of practice. I don't know if you got the video started right away. If you did, you should have approximately 20 minutes to work on the assignment. If you got a little bit of a late start, you should have maybe 15 minutes to work on the assignment. Get yourself started, and then I'll be back on Monday, and we'll take care of some more complicated examples of proofs using the idea of corresponding parts. Okay? So get to work on the assignment. Excuse me. Make sure you're not wearing a hat in my classroom. I'll get crabby at you guys. And then we'll have a great weekend, and we'll see everyone on Monday. All right?